Welcome back to a new data science project. In this video, we are going to be creating a data science project for predicting the employee performance scores. We are going to do data analysis, data cleaning, feature engineering. We are going to train machine learning models. And at the end, we are going to create a Streamlit web app for deploying our model. You can see the final web app that we are going to create in this video from the screen right now. Also, I'm going to be sharing the dataset link in the description of this video. You can check that link for reaching to the dataset. Let's start coding. So we are in the Kaggle page of the dataset that we are going to be using in this video. I'm going to be leaving the dataset link in the description of this video. You can come to this website and use download button for downloading the dataset and applying the codes that you see in the video by yourself. And in here, I'm going to talk about the dataset a little bit. Then we can explore the dataset more in the code editor. So our dataset title is Employee Performance and Productivity Data, and it says Comprehensive Employee Data for Performance, Productivity, and Human Resources Analysis. So in here we have a summary, we have the description for the columns. In here we are going to talk about them in the code editor. I'm just skipping it. So we have 20 columns and we can see that it's stored in a one file like this. You are going to be downloading this file, and we have the employee ID, department, gender, values like that. I'm going to show you the target. This is going to be our target. We are going to try to predict the performance score of the employee with the selected features that we are going to be selecting in the coding part. So we are going to get a value at the end from 1 to 5, and we are going to give that in a Streamlit web app to the user. Okay, again, this dataset link in the description. You can reach that Kaggle page from the description of this video, and you can download using the download button. Great, let's get to the code editor. I'm in the Visual Studio Code interface right now. I'm going to close this welcome page and I'm going to show you the file that I created. For adding the link in the dataset, it's going to be in the description. You can check that from there. And I'm going to create two files, one named app.py for writing my Streamlit notes from the first place. And then we are going to code the Streamlit web app in this app.py file. And I'm going to create a file like notebook.ipmb, like we can say like analysis and modeling notebook. We are going to do the data analysis and modeling side of things in here. And I'm going to take this to first place like this. I'm going to select my kernel 3.11.4. Now our dataset is ready in this place. So we are going to read it using pandas. I'm going to say import pandas as PD. Next up, I will say pandas read CSV. And I'm going to copy this file name in here quickly, like this, and I'm going to paste it in here. Now we can see if the dataset is loading successfully or not. Okay, we can load the dataset successfully. Sometimes maybe we need to specify encoding or something like that, so I generally go like this. Next up, I'm going to save it to something like data, and from now on I can call data frame functions from it. Like I will say data.head, and it's going to return me the first 5 rows of the dataset, and it's defaultly 5. You can pass a number in here like 10, and you are going to see the top 10 rows. And if you say 3, you are going to see the first 3, and you can say tail for getting the last 3 rows, defaultly 5. Okay, let's get the first 5 and talk about our dataset. So in here we can see that we have employee ID, I think it's the primary key, and we have a mixed data with strings, floats, and integers. So we have a lot of like columns in the dataset, and of course we are not going to use all of them. So I'm going to start by just taking a look at data. Next up, I'm going to be deleting some of these columns. So we can reach the data column like this, and we have the column list in here. But I'm going to take a look at the target column we have, performance score. So we are going to be trying to predict the performance score. Great. Also, we can call data information like this, and we can see that we have these data types like 1 boolean, 2 floats, 12 integers, and 5 objects, and our memory usage, non-null value count. Okay, so let's continue with deleting some of the columns because it's going to be more simpler for us to analyze this data set. So I will say data.drop, and I'm going to specify columns like this. I'm going to give the list. Firstly, I don't want employee ID, and Next up, I'm going to check. I don't want hire date, and I'm going to look. I don't want to work hours per week. I don't want actually overtime hours can be remain. I don't want the sick days. Next up, I don't want the remote work frequency and also team size. And I'm not going to get training hours too. I'm going to take the promotions. I think we can get employee satisfaction score, and I'm going to drop this resigned. So I'm going to make this run, and we are going to have a new data frame, but this code didn't modify the original data that we saved. So for it to modify, we can do two things. Like you can see when I call the data, it's like this, but when I make this run, we get a data frame like this. We can either say data equals to this, or we can say after giving the list on the columns, we can say in place equals to true. So in this way, we are going to have our data updated with the columns that we want. Great. Now we have 12 columns in our data set. Okay, let's start by checking the NA and duplicated values. For checking the NA values, we can say data is NA, and it's going to return us booleans cell-wise. Like every cell is false or true, we can say sum for seeing it column-wise, like this, and we can say sum again for seeing the total NA count. Okay, we don't have any. Great. Let's check the duplicates. Now it's going to return me booleans for every row, and if I say sum after that, I'm going to get the total duplicated count. Okay, great. So we don't have any duplicates too in the dataset. If you are going to add this project to your portfolio, you can add comments like no duplicates and NA values found, or something like that. Also in the plots, group bys, you can add comments like this to your Jupyter notebook. Great. So I'm going to call datahead2 and check what we can do. So firstly, I'm curious about department-wise monthly salaries. So I will say data group by. I'm going to group my data by department, and I'm going to take the values of monthly salary and the mean of this, like this. So I'm going to just sort this pandas series. By the way, this group by results pandas series, and which means you can easily manipulate it. And if you say reset index at the end, you are going to have a data frame with this group by operation. But we don't need that. I'm going to say sort values, and I'm going to specify like ascending equals to false. So I'm going to have a descending list here. And the leading department is engineering salary wise, and IT is following. At the last place we have the marketing. Great. So we can create a plot of this. Like I can say that plot, and I am going to create a I'm going to create a bar plot. Now we are going to have a plot on this information, and we can make this look better from adding title and ylabel from matplotlib. So I will say import matplotlib.pyplot as plt, and I'm going to say plt.title. I'm going to give it a title like average salaries by department, and I will say ylabel average salary xlabel department, and I'm going to add plt.show at the end of this. So it's going to be removing this, by the way, this plt.show, and we don't have a plot since we don't make this cell run. So I'm going to make this run, and now we have a nice looking plot over here. Great. Also, you can specify the color, like if you don't want blue, you can say color, and you can say color map, let's say wire this, and we are going to have a bar chart like this. Great. So let's continue. I'm going to just scroll down from here. Next, I'm going to call data head, and I'm curious about our target. Like I'm going to get the value counts on the performance score. So I will say data performance score and I'm going to say value counts. So we are going to have this. We generally have ones, like they're really small difference. Like I can create a pie chart from this and we can see it in a visual way. So I will say dot plot again on the series. I'm going to specify the kind as pie. I will say and show. Next up we can say plt.title and we can give it a title like performance score counts. Now I'm going to make this run and we have an unnecessary y label in here, so I will say y label and it's going to be an empty string for making it disappear. Great. So also let's add a legend to this, like I will say legend equals to true. So we are going to have this one. It is not necessary we can see colors, but I like adding legends to the graphs and we can see that they are like equal in the side. So let's continue. I will say data head 2 again and let's see what else we can do. We can get the value counts on the gender, like data gender value counts, and we can see the distribution in here. We have equally amount of male and female, we have 4,000 others, and let's see department wise years at company. So I will say data group by, I'm going to group my data by department and I'm going to say years at company and I'm going to take the mean on this like that. So again we can sort it using sort values ascending false like this, and we are going to have that. According to our dataset, our observations, we have the maximum mean on the marketing side and we can see the observation count on the departments, like department value counts. We have equal amount of employees in the dataset. We have great. Next up, I will say head 2 and let's see numerical summaries for the overtime hours. We can see the overtime hours like that. Actually, let's check this for all of the numerical columns. I will say data describe on this. So let's talk about all of them. At the numeric ones, we have minimum age of 22 and maximum of 60, mean age of 41. So at the years of company, we have 0 minimum and a maximum 10 years. Performance score, we have the minimum of 1, maximum of 5, and it's slightly more closer to the 1, but no big difference. At the salary side, we have the minimum of 3,000, maximum of 9,000, and mean of 6,400. And on the other side, on the overtime hours, we have the mean of 14, minimum of, actually let me check, yeah, minimum of 0 and maximum of 29. So let's check this overtime hours by department. I will say data group by. I'm going to group my data by department and I'm going to take a look at the overtime hours like this. So I will say mean. We have this series returned. I will say like sort values again on the descending side like this, and we are going to have this one right now. The values are pretty similar. Also, let's do a multi-index group by. I'm going to copy that and I'm going to pass a list instead of the actual string in here. So I will say like gender firstly. Next up, I'm going to add department and I'm going to make this run, and we have the gender wise, department wise, the average overtime hours right now. Also, we can check by performance score, like at the first place we can say department. Next up, actually let's give firstly the performance score, next department. So we are going to have like in the other way, it's going to be better in my opinion. So I'm going to delete this and I'm going to give like the performance score in here. Now I'm going to make this run and we have this, and I'm going to delete the sort values because it's making it look bad. Now we are going to have this. So in the customer support side, we have these values for different performance scores, and we can see that performance score doesn't really affecting the overtime hours by
department. I thought like maybe the better performance are not going for overtimes in the company, but it's not the case for our dataset. Great, so we have this over here. Now I want to know that how correlated these values are. So I'm going to filter out the numeric data frame, like the numeric values in the data frame. I'm going to only take the integer and float columns, like I will say data frame numeric is going to be equal to data, select data types, and I'm going to give like include number. And next up I'm going to call data frame numeric. We are going to have this. I'm going to call the correlation on this one. So I'm only interested in with my target, so I'm going to find that here performance score. So I'm going to take performance score from here like this, and we can see the correlation values. It returns panda series again. We can manipulate it like sort values ascending false, and we are going to get this. So performance score is correlated with monthly salary. For recap, we can take like -1 and 1 in the correlation side, and -1 means like strong negative and +1 means strong positive. In the strong negative we have the opposite directions, and in the one we have the similar directions. Like think it like we have two columns. If they are increasing and decreasing together at the same time, then they are positively correlated. And if they are moving in a different ways, like when one is increasing the other one is decreasing, then it's the negative correlation. And the values closer to 0, just like these one, are not really affecting the other one. Like we can take them like not correlated at all. Okay, I think that's enough for the analysis side, and we can summarize what we did in this part. We start by loading our dataset. Next up, we check the information on the dataset, and we dropped some columns in here with in place comment. In here we modified the original data frame. Next up, we continued with checking the NA and duplicated values, and we saw that we don't have any that type of values in our dataset. Next up, we checked the group bys and we did some analysis on different columns like this. We created some plots and we get value counts for some of them, and we take a look at the numerical summaries in here. And I'm continuing like we check the correlations at the end like this. Okay, now we are going to continue with feature engineering. So I'm going to call the data again, like head2, and I'm going to filter out some columns to use. Y is going to be, let's firstly specify that performance score. Y is the data performance score, and on the X side I'm going to take like, I'm going to take the years at company, and I'm going to take monthly salary, and next up I'm going to take like overtime hours, since I think it removes the performance a lot, like it affects it badly. Next I'm going to take promotions, and I'm going to take employee satisfaction score. So my X is going to be looking like this. I didn't define that. The capital one. Yeah, this is going to be my predict variables for the performance score. And now we have different scales, like at the monthly salary side we have 70, 80,000, and on the others we have zeros, ones, twos. So we need to scale this data. And I'm going to take x.columns firstly before everything. And I'm going to copy this list and I'm going to add it to my Streamlit app side as a comment like X order, and it's going to be this. So we need to give it in the same order to the model to predict. So we are going to give the model in this order in our Streamlit side. Okay, so I will say from scikit-learn that preprocessing import standard scalar. Next up I'm going to initialize it like scalar is going to be standard scalar, and firstly I'm going to do train test split before the standard scalar operation. because I don't want any kind of data leakage in scaling operation. And if you don't know about the scaling or train test split kind of concepts, you can check my machine learning tutorials playlist, where I have more than 40 videos explaining all this stuff on machine learning. So I will say from scikit-learn model selection, import train test split, and I will say xtrain, xtest, ytrain, and ytest, and it's going to be equal to the train test split x, y test size of 0.2. So I'm summarizing the concept quickly. We are going to have two sets: training set, which xtrain and ytrain, testing set, which is xtest and ytest, and we are going to train our model using xtrain and ytrain. And then with the train model, we are going to make predictions using xtest, and we are going to compare the predictions with the ytest, which is going to be the true y values we have. Okay, so now we can do the scaling operation. I will say scaled xtrain, but it's not going to be like that. Like I will say scaled xtrain, and I will say scaled xtest. Now, firstly, I will say xtrain is going to be equal to the scalar fit transform. I'm going to pass the xtrain inside of this, and next up I'm going to make this run. Like I'm going to do the scaled xtest operation in another one. Firstly, I have my scalar fit and transform. Now our xtrain values are scaled, like you can see from here, and I'm just going to close this one out. I'm going to export this for using it in my Streamlit app. So I will say import joblib. Next up, I'm going to say joblib.dump, and I'm going to dump the scalar as scalar.pickle. So I'm going to have the scalar in here right now, and you can see from here, and I'm going to take a note like scalar is exported as scalar.pickle. So I'm going to be using that scalar in the Streamlit app for scaling the user inputs. Now we can scale the xtest. I will say xtest equals to scalar fit transform, and I will say xtest in here. So we have our xtrain and xtest ready right now. We scaled both of them. Also, I'm going to show you the xtest we have. Yeah, great. So firstly, before doing anything on the modeling side, I'm going to filter the warnings because I'm not going to be reading them. I will say warnings, filter warnings, ignore in here. Next up, we can continue with our machine learning part. Firstly, what I'm going to do is I'm going to define a function for getting the results from the models we trained. For that, I will say from scikit-learn.metrics import accuracy score, and I will say define model performance, and we are going to be passing the predictions, which is going to be taking from the model. So again, we are going to make predictions on the trained model using xtest, and we are going to compare them with ytest. So in here we are passing that predictions which we are going to be making using xtest. I will say print accuracy score on model is, and I'm going to give like format accuracy score, and actually give me a second in here, it's going to be correct right now, accuracy score, ytest, and predictions that we're passing. So we have a function that we can give the predictions from the model, and it's going to compare it with the ytest and return the accuracy score to us. Also, actually, I think I'm missing a parenthesis like this. Okay, great. Now I'm going to be importing the grid search for the hyperparameter tuning side. We are not going to train base models. For most of the models, we are going to be doing hyperparameter tuning for optimizing the performance. So we will need grid search on that side. Great. Now we can start to train machine learning models. I will say I'm going to start with logistic regression, linear model, import logistic regression. Next up, I will say logistic model, I'm going to initialize it, and I'm going to train my model using the fit method on my training data like this. So it finished. Now we can make predictions using this, like we can say predict, and we can pass xtest for example, and we get an array like this as the predictions from the model. And if you want to get individual predictions, that just like we are going to be doing on the Streamlit website, you need to give a two-dimensional array in the same order with x. Like we have the years of company at the first place 2, we have the monthly salary, let's say 30,000, but these values are scaled, so let's just say 1, 1, 1. It's going to be a simple example, and our predicted performance score is 5. Like you can do an operation like this, and you can say like you need to pass 5 values since we have 5 columns in the data. I'm going to say 0, 0, 0. Now we get the performance score prediction of 3. Again, our problem, we are predicting the performance score. So we get 3 as prediction for the 5, 0 inputs. We are going to be handling the scaling operation on the original x values on the Streamlit web website for the users of this model. So I'm continuing, like we get predictions like this. Now I'm going to store them something like logistic predictions, and it's going to be equal to this. Next up, I'm going to call my function that I defined with passing logistic predictions, and our accuracy score is 0.30. Okay, let's continue. Now we are going to try to improve this accuracy score. I'm going to continue with the k-neighbors classifier. So I will say from scikit-learn neighbors import k-neighbors classifier, and I'm going to define a parameter grid for my model to try different values on there. Like I will say number of neighbors is going to be like, I'm going to give values 3, 5, 7, 9, 11. You can extend this list, it's up to you. I'm not going to be doing that. Weights, we can give like uniform and distance. And now we are going to say grid k-neighbors. We are going to set the grid search that we imported in here for parameter tuning. And I have a tutorial on this too, by the way. If you want to learn what is hyperparameter tuning, you can check that playlist. I'm going to be setting it like k-neighbors classifier. I'm going to set the parameter grid like this. I'm going to set the cross-validation as 5, which means 5 folds we are going to have. And I'm going to make this fit on xtrain and xtest, actually ytrain, I'm sorry. Now we have this ready, and we can see the best parameters selected in our grid like this. We have 3 in the number of neighbors and distance in the weight. You can extend this list again, like you can add 1, 2, up to you. And I will say grid can dot predict, and I'm going to be passing the xtest, like we get a prediction array like this, and I'm going to store them something like predictions. So I'm going to be saving that, and I'm going to be calling the model performance function we have with the predictions we made. We have a really big improvement in here. Our accuracy score is now 0.50, it was 0.30 before. Great, so let's continue. Now I'm going to be training a support vector machines model. I will say from scikit-learn.supportVectorMachines import support vector classifier, and I'm going to initialize it like svm. We have this ready. Now I'm going to define a parameter grid, like we are going to have a regularization parameter in here. It can take values like 0.01, 0.1, 0.5, 1, and I'm going to give kernel and linear, IBF, polynomial. Great. Next up, I'm going to set my grid search on grid SVC, like grid search cross validation. I will pass SVM. Actually, it was going to be SVM, not SMV. SVM. I'm going to give parameter grid, and I'm going to set cross validation as 5. So now I'm going to make this run. I'm going to train my models using my training set ytrain, and when this finishes I will be re-recording. So it finished. Now we can make predictions with it using predict method. Like I'm going to be predicting the x test. We got an array. I'm going to store them in something like y predictions, and I will say model performance y predictions, and our accuracy score is 0.93. So it was the best performing one by far. We are going to be using this model. This is a really great accuracy score. So I'm going to export it using joblib. I will say joblib.dump, and I'm going to give grid svc like this, and I'm going to export it like model.pickle. So I'm going to have that file in here right now. I'm going to type it to here like Model is exported as model.pickle. Great. Now we can continue with Streamlit web app creation since we did feature engineering in here, like train test split, scaling operation. We export our scalar too, and we did modeling in this section. And I'm going to be closing this Jupyter notebook. Now we can start our Streamlit app. As the starting point, we are going to do our imports, like I will say import Streamlit as st, import joblib. I will say import numpy as np. So we are going to start by giving our app a title, like we can say employee performance prediction. And before starting to our app, we can just load our model and scalar in here, like scalar is going to be equal to the joblib.load scalar.pickle, the files in here. Model is going to be joblib.load model.pickle, and by loading them like this, we can use their methods like predict for the model and transform for the scalar. And I'm going to add a divider in here. I use them a lot when I'm coding in Streamlit. I think they make the app look better. We will say you can get a performance estimation for employee after entering the values and hitting, let's say, pressing to the predict button. And next up, I'm going to add another divider. And now we are going to take our inputs from user. Let's go with the same order as this x. So I will say years, and it's going to be equal to Streamlit number input, and it can take like label is going to be enter the years at company, and minimum value can be like 0 and maximum value can be like 15 and default value can be 2. So I'm going to continue by the monthly salary, like Streamlit number input, enter monthly salary, and minimum can be 1000 and maximum can be 100,000, and I'm going to set the value as 5000. Next up, I will say like overtime, and it's going to be Streamlit number input, enter overtime hours, and I'm going to be giving like minimum value of 0, maximum value of 100, and default value can be 0. Next up, I'm going to be entering the promotions number input. We will say enter promotions, and I will say minimum value of 2. I'm going to say minimum value 0 and maximum value 10, and default value can be 0. Next up, it's going to be the last one, I think. Yeah, employee satisfaction score. I will say satisfaction, and it's going to be Streamlit number input, and I will say enter employee satisfaction, and minimum value can be 0. Actually, let's give 1, and maximum value can be 5. Like minimum value can be 0 too. I'm going to add that. And actually, I want this to be float, so I'm going to add it like this, and the default value is going to be 2.0. Okay, so I'm going to specify it like this. So we have our inputs ready in here. I'm going to add another divider, and I'm going to set my x in here, like x is going to be equal to the taken features, like we have year firstly, and salary second, overtime third, promotions, and satisfaction. Again, it's in this order. So we applied all of them. Now we can delete these comments up in here like this, and we can continue with our button. I will say prediction button is going to be equal to Streamlit.button and predict the performance score, and I'm going to add score to here too. Next up, I'm going to say Streamlit.divider again, Firstly, I will say if the button is applied, I'm going to write the else. Please use the button for the prediction. And if the button is applied, we are writing this else because it's going to be running if the button is not applied. And if it's applied, we will say x1 is going to be equal to the numpy array. We are going to turn this into an array by passing x in here. Next, I will say x array, and I'm going to use my scalar that I loaded in here. I will use transform method, not fit. I will pass transform, and I'm going to add a layer like this with brackets. Next up, I will say prediction is going to be equal to the model.predict, and we will say x array, and we are going to take the first element of this. We are going to reach to the prediction, and I'm going to say streamlit.write, and I will say prediction for the performance score is, and we can say this is an f string like this, and we can give the prediction in here like this. Also, we can add a little animation when the button is applied, like streamlit balloons. And let's test our app, and if it's working, let's use it. So I saved my file, and I'm going to open the terminal, and I will say streamlit run app.py. Now the streamlit app is opened in my browser. If it's not opened in your browser, you can just copy this address in here, and this one, the localhost one, you can paste that in your browser. You can use any browser on this operation, and when you paste this in your browser, you are going to see the app that we just created. So you can either click from here, or you can just do copy paste in here. And I'm going to be re-recording in the browser in a second. So here is our app, employee performance score prediction. By the way, you can change its settings, like you can say light or dark, up to you. And I will say light. Let's read it. You can get a performance estimation for employee after entering the values and pressing to the predict button. So we have default values in here, and let's firstly take a look at the base values. It says please use the button for the prediction. We do this and we get balloons, and the prediction for the performance score is 1. So our app is working smoothly. So let's continue, like let's add a salary of 8,000. Let's add a years at company like 5. Let's add the overtime hours like 10, and let's add a promotion like 3, and let's add a employee satisfaction like 4.1. So let's predict the performance. Now it's 3. Nice. So it's working smoothly, and it's giving us predictions for the performance score. We can see that our app is great, and I'm going to make it run again, and we get the performance score of 5. So according to the chains in here, our app is changing the prediction, and our web app is giving the machine learning predictions to us in a really good interface. Great. So I'm going to change this to 2000, and now it's 1. Great. This is our app, and it's working smoothly. Like I'm going to make a one last try. Now we have this. Okay. Let's summarize what we have on the Streamlit side, and then we can finish this tutorial. So we start by importing Streamlit for the web app, Joblib for loading the scalar and model, and NumPy for the array operations. Then we give our app a title. We write like you can get a performance estimation for employee after entering the values, and we take the user inputs in here. Then we store them in something like X. Remember, it needs to be same order with the X that you train your model on. Then we define a button like this, and if button is applied, we are doing these operations, else we are doing this, like we are writing please use the button. And when the button is applied, we turn our X into an array. Then we add an extra dimension on the scalar.transform for passing a two-dimensional array on model.predict, and we scale our data. Next up, we get a prediction and reach to the prediction. Then we appear a little animation, little balloon animation that you see when we use the button, and at the end we write the prediction for the performance score is this to the user. And in this kind of app, user can enter to it and enter their values and get its estimation for the performance score. Great.
Thanks for watching this data science project. I have a data science projects playlist where I have more than 30 projects just like this one. You can reach that playlist from the cards of this video or from the link in the description. Also, I'm sharing a new data science video every week on my channel. You can subscribe to my channel for more videos like this. Have a great day.